Hello.
Hey, Yuri.
Can you hear me okay?
Yeah, you sound good. How about me?
Oh, yeah. Yeah.
Um,
Um,
you settling back in from your vacation fully now?
yeah, it took forever to switch. I think it's maybe it's because it was for like almost for 2.5 weeks, so it takes longer. Uh,
Oh, you mean the time zone?
yeah, so we were there for quite a long time, so maybe that's why the switching took,
Yeah. Have you ever you try melatonin?
So we had melatonin, but my wife uses it. Um, I didn't try it when we came back. No.
Yeah, that's usually when I only time I use melatonin is well, I haven't done it in a long time when I used to go to England or Europe. When you come back, just those first couple nights to try to help a little bit. But it's
So,
for everybody. Everybody reacts differently to that kind of stuff.
uh,
It looks like CG is going to be a couple minutes late.
oh, okay. I should have a meeting at 1:30 at work, so uh, uh,
Well, when he
I
gets on,
will.
we. Mhm.
Yeah, I will leave. Um, or try to reschedule a meeting. We'll see how it goes.
Yep. Okay. Well, if he gets on, well, I'll have you ask whatever questions you have, or as soon as he gets on. Do you have much experience with the difference between cosine, distance, and Euclidean? I was reading about it a little bit, trying to understand that.
Um,
I mean,
yeah, yeah.
do you have any experience? Like my basic question, really, to give you a simple way to think about it, is I think in general, when you're doing NLP, people tend to use cosine.
Yes. So my hesitation was that we I had this conversation at work yesterday. So we have a network where we actually use cosine similarity as a measure. So right, so we're doing mapping and then using cosine similarity to pick the closest vector. But then somebody was developing a model and they said, well, you still need to normalize vectors even though you're using cosine similarity, which made no sense. So I still don't know, I think maybe they basically then do something on top of that. But yeah, so cosine, I think people use cosine similarity because you don't want the length of your vector to influence.
Right. It's just the angle. It's measuring the angle.
Yeah. And I think, and again, this is hand waving argument. I think in multidimensional space, angle matters a lot more than distance because distances are huge.
Oh, yeah, yeah, because it's sparse and
Yeah.
huge space, right?
Yeah.
Yeah, yeah. That's the NLP argument for using why people use cosine for sure.
Yeah.
Right. So have you ever used Euclidean for some reason?
Um, so I think so not in my network, but somebody else's network, they used both. But also it also like kind of just like to what I was talking before, it's also matters whether your vectors are, normalized or somewhat kept at the similar distance. Again, with NLP, uh, you know, we use sum. So we take a phrase and sum up all the vectors for all the tokens. Some people use average. Average will give you like shorter vector, right? Because it will divide by number of tokens, basically. So with average distance, Euclidean distance would make more sense.
Would you
It,
actually expect a Euclidean to perform better when things are normalized like that than cosine? Because you still have.
um, No, but like strangely, people sometimes get better results with different distances. Like I've seen it once or twice.
Yeah, it's experimental. I mean, you experiment and see. I guess you'd have to know what situation it's worth trying Euclidean in. But TF-IDF, that's normalized space, right? In general, because your TF-IDF in and of itself, because it's kind of old school, right? But if you're just doing TF-IDF, your numbers between 0 and 1 always.
Yeah. Oh, yeah.
So, but people still use cosine and NLP when you have normalized vectors in that case, I think. So maybe it's just still the sparsity of it, still cosine's better, even when you have normalized. I don't know. I'm just trying to struggle with totally understanding that.
Okay, so the main difference, and then this is me like thinking, the main difference is whether your vectors have length or have length of 1, basically. That's the difference.
Well, so there's length, and then there's normalized length, 0 to 1, right? And then length is just unbounded. Then there's normalized, which is 0 to 1.
No. But normalized to me, when you say normalized, so maybe we're thinking about different things. So when I say normalized vector, I'm thinking vector of length 1.
Oh, you're thinking binary vector.
Because what you do is you normalize it by. I'm thinking you normalize it by basically divide everything by the length of the vector, every element.
That's the L1 norm, and divide by root over sum of the squares.
Yep. Yeah.
Well, what you're doing is you're putting it into a normal distribution, right?
No, but that's each vector,
Yeah, no, I know what you're saying, but you're centering your vector's length or weight on.
No, but length would be exactly 1 for those vectors.
I think you are thinking of like normalizing in a different way, right? You're thinking of taking all those and, well, how would you put in a normal distribution? I'm not sure. But basically, using an L2 norm to make this, normalize your vectors in the way Yuri is mentioning, allows you to use dot product instead of cosine similarity, because essentially, because you have taken the denominator, the norms of the two vectors that you're dot producting, that essentially is the cosine similarity. So it's easier in the sense that this is something you would have to do every time anyway. So you're just doing it ahead of time and norming them so that you just do a dot product instead. You save yourself the extra calculation.
So we started the discussion, but I started the discussion by trying to understand. In NLP, you almost always use cosine distance to measure distance between vectors. But what are the cases when you use Euclidean? I guess I know Euclidean. Cosine is good because the sparsity of the data and the length and all that, it measures the angle. But when do you start thinking about using Euclidean?
Yeah, I actually came in when Yuri mentioned this, and that was a piece of insight that I hadn't actually thought of. He said that, when you use Euclidean, only when was that? Now I'm drawing a blank again. Yuri, you mentioned that you use Euclidean in one case where it works better. But then you said you just try which is better. But before that, you said something about
So what we did is, and again, this is again what I started with is we actually have like a strange behavior.
Averaging. Sorry, yeah.
Yeah. So there was always a choice, right? Do we average or sum up? And we ended up doing the sum, but then normalizing the vector. And I don't understand. And I tried averaging also in other networks, but the strange thing that I see in so apparently we use cosine similarity, but normalization still somehow still helps, but it's normalization of the input vectors. So maybe because we have input vectors and we have output vectors, and we're comparing output vectors. So normalization of the input vectors also helped in our, which it shouldn't, right? Like a neural network should take care of it, but somehow that helped. And that's not answering your question about the distance at all. That I'm just like talking to myself mostly.
Talking about neural networks, I think now I understand what Darren's idea of normalization. I think you're thinking of batch norm, right? Where you're normalizing, you're taking all the weights and you're forcing them into like a, kind of pushing them into a normal distribution, cutting off outliers and so on. Right. So I think maybe
I'm asking even a simple question from the beginning, which is simply I started reading about cosine versus Euclidean, and in just at a very basic level, what the difference is. Cosine is usually used in NLP and why. And then I'm just like, well, what are the situations where you use Euclidean? And it seems like you use Euclidean when you have normalized. I guess I misunderstood what they meant by normalized vector. So that's really.
I think Euclidean would make sense when you have normalized vectors, because otherwise you might have very large, there might be, the distances might be inordinately large, right?
So when you say normalized vectors there, do you mean
unit length?
Normalized, like say you had 100 documents, all of that would be in a normalized space, or do you mean within the vector each dimension?
So assume you generated vectors for these 100 documents, right? And some of these, the sum of the squares, the root over the sum of the squares for some of these vectors exceed 1. So you basically turn them into 1, right? So you basically divide by the L2 norm, basically, right? And once you do that, every vector is, of unit length 1. Now, if you imagine it in like a high dimensional space or even a 3-dimensional space, right? So if you have some vectors which are very long and some vectors which are very short, the distance, the Euclidean distance between them is going to be stretched, right? But if everything is sized 1, of size 1, then you would actually see the, the distance between the two, the Euclidean distance between the two would be comparable across different documents, regardless of their.
So when you say vector equals 1, each vector, you mean all of the dimensions sum up to 1 within a vector?
Largely, I actually mean that I think of L2 norm as much better. So I think of the sum of the square root of the sum of the squares of the dimension elements of each. Yeah.
Okay.
But there's so my general thing is to try both. Just like Yuri mentioned. And the only one time I've seen Euclidean outperform cosine is when I was doing this keyword thing. I talked about this some time back. Is basically I used autophrase to generate keywords, and then I did something to find, most appropriate keywords for something, right? I don't remember exactly what, but I used Euclidean, I know that, and that gave me better results.
Okay, I get it. All right. Well, I don't want to keep us stuck on this. That makes sense. Thanks, guys. I think that Yuri has a meeting in like 10, 15 minutes. So I thought we'd give him the floor to start off with here to share or ask questions or.
Okay. Yeah, I might also I will see I might try to postpone it, but oh yeah. So don't have a lot to show. So I listened to some of the graph conference yesterday, and for Hugging Face conference, I started listening to the YouTube. I don't know. Well, I don't have a conclusion yet. Most surprising thing is that the titles are always misleading. I always try to I look at the title and I think, oh, that would be useful to me, and then it's it's I don't know. it's impossible. Like a title, I don't know. In both of those, conferences, titles were completely like I don't know.
We need a generative model for generating truthful titles.
Yeah. Because there was like NLP and knowledge base, and I was like so excited, and it was like a theoretical exercise. I don't know. It was more on NLU, so yeah.
So the Hugging Face at Work stuff, is that available now?
Yeah. Yeah. I think. Yeah. I'll post it.
And so, out of the Hugging Face at Work, were there any others? Was there anything of interest you saw? Or?
I only like listened to like one or two, but they're all it's right on the topic. It's on information retrieval, like bunch of different So I still have to like go through it.
And how with the Graph conference, was there anything that stood out, or other than the titles being misleading?
So there's a library now called PyGraph. That's
GraphGym.
There's GraphGym, but also the
PyG is PyGeometric, no? Or is it PyGraph? Okay.
No, PyGeometric. Sorry, PyGeometric 2.0. So where they basically kind of, I think this is like mid-half listening. Basically, they implemented all the research projects from like last year into PyGeometric, plus they have heterogeneous graphs. So they have like a new implementation.
Remind me what heterogeneous graphs are.
Like a different types of edges, I think.
Nodes can be of different types, not edges.
Oh, nodes also.
Product and users and whatnot, right? So
that's heterogeneous. Geez,
that's heterogeneous.
I thought that's funny. So in the GraphML world, that's like a big thing, right?
Yes.
But in the Neo4j property graph world, that's
there are still heterogeneous graphs, but it's harder to work with using graph neural networks. So in the 224W, the CS224W graph thing that we were also, that's on 2ML as well. They had a few collabs towards the end, I think collab 3 or 4, where they actually implemented heterogeneous graphs. And the way they do it is by considering each of these sets of nodes independently, right? So when you're passing in the messages, you treat all the messages, you basically take all the neighbor juice, right, from your own kind, basically, right? So you have to basically treat them separately. It's a little more complicated programming, but now they have basically, put it in the framework, so you can just use it.
I guess the key thing, that's interesting. The key thing is when you do heterogeneous message passaging, are all the types of entities still in the same vector space? Can you still do all the typical stuff with the trained graph, where you similarity stuff and classification and all that?
Yes.
Still work across entities?
They don't actually, from the outside, they work across entities, but the way you do message passing is you do it within entities.
Yeah. No, I understand that, but that's why I'm wondering is if you can then, once you've built those embeddings or whatever, can you then give
you can do graph similarity. If you do, for instance, if you're looking for isomorphisms, right, a particular set of users and products somehow tied together, right? So if you're looking for that same pattern to repeat, elsewhere in the graph, or if you're looking for identical graphs like toxicity, there is an example, right, where they try to figure out which molecules are toxic, and those are heterogeneous graphs because they have different atoms representing nodes, right? Hydrogen is one kind of node, carbon is another kind of node, and so on.
Right.
And so it works basically from the outside. It is, it's the same vector, right? But inside, the message passing occurs within entities, not across entities.
Yeah, I get it. That's interesting. And so, when would you think about using PyGeometric? does it cover everything, or is it just more like, you would use it mainly when you're doing GraphML, and it has multiple training methods in it? Is it one of those kind of libraries?
Multiple training methods and graph GNN layers. Also pooling methods, right? So how would you take node vectors and pool them into a graph? So they have different specialized pooling methods in there. PyGeometric is basically a leading, graph library, right? Graph neural networks library. Its competitors on, from Amazon is DGL. DGL works with PyTorch and TensorFlow. No, maybe not TensorFlow. PyTorch and MXNet backends. And on the TensorFlow/Keras side, there is Stellar Graph, I think, and one other, Spectral. So they're all kind of in the same space. They're competing with each other. The guy who was doing PyGeometric was actually asked yesterday.
I was about to say the same thing. He was very polite.
Yeah. Like he was yesterday?
He didn't want to compare. He basically said, we do what we do, kind of, I don't want to compare features, you choose, kind of,
Sure.
He said he didn't want to get into like framework wars, basically. He chose,
He's probably doing it for his own. It's just a framework for his own.
No. He's basically, that was another question everybody asked. He's finishing PhD. So one of the questions on YouTube link was like, well, after he's done with PhD, will there be a support? And basically, I think through the summer, they actually have a large group of people like, working on it from a bunch of companies. And that's what they were trying to say, that it's not a research project. It's basically, I guess, whoever supports, PyTorch, Facebook and such will support it.
Yeah, I think Stanford is jumping in as well. So
yeah, it was Stanford and one more school. Yeah, where he was.
TU Dortmund. That's, I think, where he's from.
Yep.
And so Stanford is also jumping in. So there'll be a bunch of guys who will start, contributing as well.
Yeah. One thing is, I'm kind of interested. I want to ask Darren about the book he posted, but also I just noticed somebody posted on General, and he's working in SemEval challenge and looking for people to work with. So I might reach out and ask. So, but yeah. So I don't know, Darren. So you posted a link to is it the book and the video?
Multilingual, okay. Ashish Salanke, okay. And you have voted it, all right. Or not, like thumbed up it.
Yeah.
Okay.
Hey guys. I'm back.
Oh, okay.
Hey, yeah, I wanted to I'll ask you quickly. So, is the video, like you posted video in the book? Is video good enough, or is the book like better, or?
Which are you talking about?
Oh, Darren posted the
I see,
knowledge graph, enterprise knowledge graph video in the book.
Oh, okay. Yeah, I don't have it.
Okay, so can you hear me okay?
Yeah.
Okay. So I have no idea about the book. The reason I found about that book is because it comes out of that guy who talks in the video. So the video is quick. It's pretty quick. It's like, I think it's like 15 minutes. And the guy in it is obviously very knowledgeable. And so I would just say, listen to the video. If you like the video, read the book. Now, the only thing is it's very much it's really, the perspective is very outside of what we're doing. It's enterprise data integration.
Yeah.
Right. And so I wanted to understand just the position of graphs and enterprise data integration. The interesting thing is it led me to MDM, master data management. You guys familiar with that?
No.
So that's this is the database IT folks, and there's this MDM, and what MDM, it's been around for a while, and master data management, basically you create authority lists or entities, right? And those entities have IDs, and the IDs allow you to pull in your record for that person or that company or whatever the entity is, right? From records across different databases. So it's a way of aggregating your data across data sets. Now I'm like, this is exactly what enterprise knowledge graphs do, right? Because the whole thing is you basically identify the most important entities to your company, like customers, and a handful of them, and then you pull all your data into your knowledge graph, and then you can do analytic queries across all of those, right? Entities with all of your data across your enterprise. And so then I was researching knowledge knowledge graphs like like Neo4j, and knowledge graphs and MDM, and Neo4j is trying to be the newer MDM solution, right? So they're actually selling their knowledge graph as an MDM solution. Now, most MDM solutions are SQL based, and they've been around a long time. So that whole idea of taking all of your data in your enterprise and then sucking it into these key entities with relationships, right? And that modeling by key entities, I think is just intuitively very, very useful, and it's here to stay. So, but that's all. I was just trying to connect all those dots. So that's what the video is. It's short. It shows that really pure enterprise. They call it enterprise knowledge graphs perspective. Anyway.
Okay. Yeah, I think I'm going to jump into the other meeting. Yeah.
Okay. Well, we'll talk next week.
Okay.
Thanks.
Right.
Thanks, Yuri. And I got nothing too. So not really. I mean, not much, except that I attended the graph thing yesterday. Part of it, I skipped the industry panels. So, and I think the PyGeometric, I still have to go through. I attended the last bit. I couldn't attend the full thing because I had something else.
Yep.
Yeah.
Okay. And I really don't have much except for what I tweeted, which was the titles, and that the Can PyOD, method, different titles. Yeah, but I'm stuck now because the titles they're still accurate articles, right? So it doesn't really give me a re-ranking in terms of the topic of Cloud Native. What I really need is the full text, and I just don't have the time to get the full text right now. We don't have an easy way to do that. So I don't know if I can use that for threshold setting or re-ranking it fully realistically yet. So anyway, okay, well, that's cool. We can just call it a call.
Yeah, sure. Okay, all right.
Okay, I'll talk to you next week.
All right. Bye.